is given. But sometimes I can give the average record length, 100 bytes. You can calculate the blocking factor. Then 100 rows means how many blocks? 20 blocks. Okay, so this is an unordered file. On average, to search the data, how many blocks do you need to access? How many? One. So this file organized how many blocks? 20 blocks, 0 to 19. Some data is here, some data is here. So unordered file, heap file, need to use sequential search. How many blocks? If you are not lucky, how many? 20. Okay. If you are lucky, 1. So on average, it's a 10. How? So accessing the speed of the unordered file is B/2. Okay? That is a sequential search. That is what you learn in your data structure class, in your freshman, if you remind. So B/2. This is an unordered file. Benefit, unordered file, it's very simple to implement. Problem, it takes this one to search the data. So there is another one, it's an ordered file. Ordered file is whenever we insert the data, we need to check by the key. 1, 2, 3, another block, 4, 5, 6, and so on. So this is called ordered file. Same thing. In case of ordered file, how long it takes? What is the cost to access the data? Ordered file. 1, 2. How can you search the data in case of ordered file? How can you search? Brute force? You can do binary search. Cut in half. So I will search 10. Cut in half, whether 10 is here or here, and cut in half. And what is the complexity of the binary search? Log. So log. So which one is faster? B/2 or the log B?
Log.
Definitely log B is faster. Ordered file is faster. So ordered file is faster. Problem? Whenever you insert the data, you need to search and insert. So that is the ordered file. Another approach, ordered file, another approach is we can use the hash. What is a hash? Every time when I teach this one, I ask, what is a hash? Hash is the data structure, yes. What kind of data structure? It's to store the data. It's for the
path. The path of the
path. What kind of path? It's a function. Hash is a function. Function for what? To make complicated data into simple one. Complex into simple. For example, what is the example, very well-known example of the hash function? Modular. Modular by 5, for example. What happened? Whatever the input data you have, it will be one of this. Right? It's very simple. Characteristic, hash function is one way. You cannot go back, as you can see. So, using hash function, so we can store the data by hash value. That is called the hash bucket. Bucket for 0. Hash bucket for 1. So, input data, apply hash function, then go to here. So, when you search, you can apply the same hash function then data will be here. How can you speed up? Search area is already narrowed down 20%. So 5 times faster. Without using such a binary search or whatever, using only hash is very fast, so you can speed up. This is a hash approach. So keep in mind, hash is very useful and approach, especially for the such a search and the security reason. It's one way. It cannot be recovered, so it's secure. Problem? If you remind your data structure class, hash has several problem. The most important problem is collision problem, which means different data, 2 and 7 will be same. Okay? To address such a collision, there are several approaches if you remind. Open addressing and what else? The chaining and hash over hash, extendable hash, so you can apply such a thing for the databases. I'm not going to explain in detail. So these are the basic file structure that we are going to use in the classroom. Let me quickly go over. What is the time? So we have 10 more minutes. So this is a record that blocking. So keep in mind what is the blocking, and the blocking is used for the I/O. That because of that we are going to use the block to calculate the cost of the operation, the blocking. There are 2 types of the record. One is unspent, another one is spent. Unspent means the one record should be together, okay, not chain. On the other hand, the spent is the flexible. You can chain. Problem? You need more I/O for the spent one. These are the operations. It's very similar as well. File structure you learned in the operating system, because database use the same file structure defined in the operating system, especially in the file system. Okay, but the couple of more the new operation like the reorganization and find the next such the operation you can add for the database file structure. First, unordered file is a heap. Okay. So as you can see, so this is the unordered. This is the ordered file. Unordered file, just we can use the linear search, but ordered file. This is ordered by what? The name. Okay. Each one is the block. So when you access, for example, the gen occurs, the entire block will be returned to the memory. Then it can be reused later. So that is the average access time, as we have seen the B/2 for the unordered file, but ordered file the log B. Even though ordered file, if you are using the sequential search or brute force or the linear search, it will be also the B/2. Keep in mind, this B is not the number of record. Always block. We already talked about this blocking a lot. So when we measure the cost of the read and write, it's always block by block, number of block. Okay. Hashed file we did. Okay. The collision is the biggest problem, or it's a general problem of any application that use the hash. Okay. So to address that one, there are different approaches. I'm going to skip this. Because of this, usually it's not only hash. Most of the block, if block is filled 100%, there's no flexibility. This is also the practically very important things that when you design and when you manage the database, we are not going to we are not going to use 100% of the block. On average, usually even 70, 80 is too high. Around 60 to 70. 2/3 of the block we use, which means 1/3 usually free. It's not used. It's a waste of space, but it will be used later in future. Otherwise, it will be disaster. If you fill up 100%, no flexibility, your system will be drastically lose the performance. Because of that, in general, in general we use the 70 to 60% of the each block. So hash is also the same thing. Okay. I'm going to skip the rate part. You don't have to worry about rate, but just for your the common sense, you should know the one. Two of them. One is a rate 0, another one is a rate 1. What's a rate? Long time ago, 20, 30 years ago, like when we purchased the 32 gigabyte with the $300,000, so it was very, very expensive hard disk drive. So our goal is maximize the utilization, but problem is should be safe. So with the keeping the reliability, which means in case we lose the one hard disk drive, should be recoverable. So at that time we designed a different architecture of the hard disk drive that is called the RAID. It's called the redundant array of inexpensive disk. Nowadays, this is not a big deal because hard disk drive, the 1 terabyte is the 100, less than 100, even SSD is the $300. So, but among them, this RAID 0 and the RAID 1 is the used still. RAID 0 means it's no redundant, but it's a striping. Okay, striping means data is block 0, block 1, 2, 3, 4, like this one. But we separate the employee table, block 0, block 1, block 2, block 3. Department, block 0, block 1, block 2. Stripe. Why? Why do we need to stripe? It's for parallel processing. We can access the employee 0 block, 1, 2, 3, same time. Okay? That is the parallel speed of purpose, the striping. RAID 1 is mirrored. What is a mirror? Same copy. Why? Reliability. In case we lose the hard disk, as I said, the hard disk drive itself is a lot of mechanical operation, maybe damage it easily. In case we lose the data, recover with the mirrored. But problem is utilization. What is the utilization of the mirrored? 50. You can use only half. But nowadays it's not a big deal. It's cheap. Enough to buy even the 7, 8 times of mirror. For example, Bank of America has at least 7 copies. So if you make the transaction, it will be this will be 7. Even each mirror is not in the same location. It's in the different location to avoid any disaster. So that is 0 plus 1 means striping, then mirror. There is another one, 1 plus 0. Mirror first and striping. They are slightly different in terms of operation. So which one is first? So if you read like the RFP, request for proposal, okay, you should be able to understand. So they need RAID 0 plus 1. They need 1 plus 0. So you should be able to understand what does it mean. So they need the mirrored so how many copies of mirror, and they need the parallel. So like the striping. So not directly use the RAID technology, but that terminology is still used. 0 plus 1, 1 plus 0. You don't have to worry about. But if you are interested in the RAID, still some of the old legacy system use RAID 5. Only RAID 5 you need to understand. I'm going to skip this part. Mostly discussing the operating system. This is actually the first disk box that we purchased from EMC, and this is the storage configuration that I use with the database configuration. It's actually I make this diagram. It's 1998 probably, so almost 20 years ago. At the time, it was 20-something the instances I managed, and mostly Oracle. There are Informix also, and this is called the DMZ. To make the secure the location in terms of the network. It's the first time to set up the DMZ, Okay. Nowadays it's popular, but it was not at the time. So this is the 5 part that we discussed. Okay. Then plus, so 5 structure is very similar as one you learned in the operating system. The major difference is in the indexing structure. The 5, as you can see, the fastest way is either this one, log B, or the hashing. Even the log B, what is the linear is definitely like this. The more data you have, like this. Log B is still better, but still, the more data you have, longer time it takes. So we need to lower the speed, complexity. So how can we do that? We need to consider new data structure, that is the indexing data structure. So indexing is one of the several important techniques used in the DBMS. So one is the query optimizer and the query processing. Another one is the buffer management. Buffer management, we are not going to discuss detail, but I will introduce. It's the LRU algorithm is used to listen to the use. And another one is the indexing structure. So indexing is from the data structure point of view, we can speed up to access the data. So we will see the next class, what is the indexing structure, how we can speed up. Have you ever heard about the B+3 or B3 index? What is a B3 index? Binary? So forget about the binary tree. Nobody uses a binary tree in the database. When we are talking about the B3 index or B+3 in database, it's a balanced tree. If you go back, remind, when you learn the tree structure in your freshman, the tree structure looks good, but when? It's a balanced. Otherwise, if not balanced, extreme case is skewed like this one. This is a tree, but extreme case is skewed. This is the same as what? Linked list. This will be the linked list. So it should be balanced, the same level of left and right hand side. So when we talk about the tree index structure in database, B3 and B+3. B+3 is 99.99% of the indexing in relational database use the B+3 structure. At the time, B stands for balanced is important, not binary. So we will see how such an indexing structure is organized in the next class. We'll continue the database. Any questions? Okay, so we will see on Wednesday, and we'll a little bit speed up to cover the other topics.